Hello, you wonderful people over at YouTube.com. Today, I'm going to be showing you how to make a planet-like gravity on a square instead of a circle. Okay, so first off, let's get into the structure of the project. The project is structured into a main scene and a player scene, and not a planet scene, because I was too lazy to make one, but you can. This is the planet. It's a rigid body. You could technically just make it a mesh instance 2D, but I wanted it to be collidable. Now, character body 2D is the player, and this icon is just to show where we are relative to the top of the planet, quote unquote. The player has a sprite, a collision shape 2D, and a camera. And the camera has ignore rotation turned off, and it has rotation smoothing on. So the code is the fun part. I'm not going to go line by line because there are 55 lines and this will take really long to explain. So I'm going to go chunk by chunk. First is this chunk. So in this chunk we have extends character body 2D, which gives us access to all the functions inside of the character body 2D node. Then we have our gravity strength constant, our gravity direction vector, which we can set to whatever we want to change what direction our gravity is. And then we have our planet node in our export scene, which we can set right here. Next we have our physics process function, and at the top we have these. And the best way I can explain these bottom two is magic, basically. But a more in-depth explanation is that this converts the where the player is relative to the planet. Like, this is 180 and negative 179. This is negative 180 and positive 179. And this is 90. This is negative 90. Stuff like that. But Godot uses radians, so we also have to convert it into degrees because I like to work with degrees instead of radians. And this right here is our actual gravity, if you could call it that. This controls our gravity detection. So basically, we're treating the cube, or the square, like it is a circle. But we're snapping the gravity direction to these 4 vectors instead of just letting it be whatever it wants to be. So for example, in a normal circle, it would always be pulling towards the center. But on a square, this would be pulling towards the center, but it would be pulling more down than it would be right, for the most part. But here, it would be pulling more right than it would be down. So we're going to make it a down vector. We're going to make this a right vector instead of a down vector. That's basically the premise of this block right here. And this here, what this does is it nudges the player down just a little bit right before they get rotated. So if the player is walking off, as soon as they get here, their gravity direction will change, but before they rotate, they get nudged down 30 pixels. And the reason for this is so that the player does not accidentally trigger this, does not actually go before the trigger zone and after the trigger zone and flipping back and forth and settling into one or the other state. I'll show you what that looks like after I finish explaining everything. Then we set the rotation so that we actually look like we are facing the direction we should based on gravity. Actually, I just decided that I'm going to show you this now. So right now, this is what it looks like. Now, if I go off of this edge, you can see that I am a little bit further down than you would expect me to be. But the reason for that is because, watch this. If I go to the edge and I don't get pushed down, did you see that? What happened was I went more, which triggered it, and then the gravity was still carrying me in this direction, and I hadn't slowed down fully yet. So I carried back up and got affected by the gravity again and went past the trigger field. So this is why we have this. Next, we have this chunk. What this does, these are basically our velocities before we set our velocity. This is our friction constant. You can make this whatever you want. You can make this 0.9 to be a little bit more slidey. I like mine at 0.8. Current move speed is exactly what it sounds like. We take our move axis, which is just our perpendicular axis to the gravity direction, because we rotate it by negative pi over 2, which is the same as 90, negative 90. And then we normalize it, which we don't have to do because we're only using the constants for the vector. But this normalize function, what it does is it constrains it to a circle instead of letting it constrains the vector to a circle around it instead of letting it go as far as it wants out in any direction. Current move speed is exactly what it sounds like. It's our velocity in this direction, in basically whatever direction, I should say. But it's along this axis. Next, we are going to multiply our current move speed by 0.8, which is basically the same as multiplying our velocity by 0.8. And then our gravity speed is the same as move axis, but it's flipped, and it hasn't had friction applied to it. It's in the normal direction. It has not been added or rotated or anything. Next, we're going to set our velocity to basically the same as it was last time. And gravity is getting added as well, even though it's also getting added down here. And correct me if I'm wrong, but you can just get rid of that. And nothing bad will happen. He moves really slowly. Because the reason that we had, I'm remembering this now, I was actually an idiot, sorry. The reason that we have this is because we need to carry on our gravity speed from the last frame. And then we add on to it because we're accelerating. Now is our input. This is basic input except for this. What is this? What are we doing with cosine and sine? Okay, so basically, for our x velocity, we are subtracting 9,000 times delta, so it's decently fast. And then, we're taking the cosine of rotation. What does this do? Basically, whenever we're taking the cosine of rotation, it gives us a number such that it's basically giving us the inverse of the Pythagorean theorem, you could say. So instead of taking these two vectors and then returning, or these two axes and then returning a vector, it's taking the completed axis, which is the rotation, which is technically a vector, but it's an angle. We're using it as an angle. And then we're just taking the x component of that vector, which is cosine. And since it's a unit vector, which is a vector that has been constrained to a circle, so a normalized vector, it is between 0 and 1. And we can use this to basically move in any direction without changing our code in pretty much any way. And same for right, except we're adding 9,000. And so, can you find the issue in this code? Is on floor, right? Well, yes, we do need this. But the way that Godot works is it uses this setting in the character body 2D to determine what the floor is. So we also have to change these things pretty much. Which means that I need to go up here and do something like up direction is equal to negative gravity direction. And this right here, this, if I'm not wrong, which I usually am wrong, but if I'm not, supposedly this time, I should be able to jump. I'm clicking and nothing is happening. Reason? Oh, that'll do it. And now we can jump. Now, our rotation isn't smooth or anything, which can get annoying for some people. I understand. But I personally like the rotation not smoothed. And what you can do if you want the rotation to look a little bit more smooth, but you don't really want to use a lerp or a tween, you can go into rotation smoothing and either turn this up. The higher that is, the slower, or the higher that is, the faster it will turn. And the reason that I don't like this is because you could also just turn it off if you want it to be really fast. I don't see a point in doing that otherwise. The only reason is that there is that flash, but I honestly like having the player directly in the middle. I think it's really fun. But I know that my friends do not like it. And so, just for you, just for them, I'll turn it down to 3. And I feel like this looks pretty good. Now, I know that not everyone is going to like this look. So, theoretically, you could go into this rotation right here, and you could use a tween to change the rotation, basically. The only problem with that I could see going wrong is this get angle to, because I have this right here having a wrap float function with a get angle to minus rotation, and get angle to minus rotation just cancels out our rotation so that we can still use our angles. You wouldn't need rotation. You would not even need this get angle to if you like made your own function and you used position to get angles instead of the get angle to function, because the get angle to function is dependent on your personal rotation. And so if you instead got rid of this and just made your own function, then you theoretically would not even need either of these lines, and you could, well, you would need this one so that you can use these, but you get the point. You wouldn't need those. So, yeah, this is the finished product. That was kind of weird. Oh, what the heck was that? What I think happened was huh. I see what happened. Yes. I went over, my gravity got changed, and then I went back over to here. I actually do not mind this as much as some other people might. As much as some other people might. Yeah, I don't think that's that bad. If you want to get rid of that, instead of having the angles go out from the cube in a circular path, like going through the corners, you could I guess you could also make them you could make them a little thinner so that they're like this instead and they don't overlap as much with the other vectors. You could make them like this. I personally like them how they are, and this video is already getting really long. Um, it's not late, so the night is young. I have a lot to do. But anyways, any tutorial ideas you guys have, put them in the comments, and I'll get to it. I'll start jumping like a rabbit. Anyways, I have nothing to do. Adios.